So yesterday and day before yesterday, we have started with our subject, and we were discussing about the very first unit of our programming in C subject. And in the very first subject unit, we are talking about certain topics which were pertaining to how to make a problem be resolved, or in the best way, how to get the solution for a problem. We'll apply our logic and we'll get the solution. But before we apply the logic, we'll create a plan to resolve it. That plan was nothing but a algorithm. So problem solving is nothing but a methodological approach or a set of techniques to find the right solution for a given problem. We have seen various steps that are required in solving a problem. There were basically four steps that were needed. First one was analyzing the problem thoroughly, getting a clarity about what is the problem. Next, developing a algorithm, that means a strategy, a plan to resolve the issue. In this strategy and plan, you will develop and write it down in plain English format so that you can easily understand it. Later on, you will convert this particular plan into actual code which can be executed on the computer. Code phase is called as coding. Once the code is available, you will try to test it out and check whether it is going to actually give the solution for the problem or not. That phase is called as testing phase. And in the testing, if you get any errors, you will try to resolve those errors. And the resolvement phase is called as debugging. So having seen all those things yesterday as well as day before yesterday, let us further to actual topic that we are going to discuss today. It was just a brief overview about what we have discussed till now, and so let us also recap back that for a given problem there may be multiple solutions, and if there are multiple solutions, there may be multiple algorithms or strategies which you have adopted to solve it. Now, which strategy or which algorithm or which plan is the best plan to get the right solution? In order to make a justification which one is best and which one is not best, we'll try to look into its characteristics. And based on the characteristics performance, we'll try to make a judgment which one is best. So we have seen various characteristics such as precision, uniqueness, fitness, input, and output. So those things we have discussed yesterday, and now coming further, uh, whenever we have an algorithm, we need to put it down on a piece of paper. We'll write it in English. Fine. In sentential point-wise format, we'll write it step one, so and so things to be done, step two, so and so things to be done for resolvement, and so on and so forth till step 5 or step 10. But if you have the knowledge, you can understand what you're doing in the steps. For a normal person who doesn't has any knowledge, how will you present it? In order to present it, we have used two different formats. Those two different formats were nothing but flowchart and pseudocode. So flowchart was basically containing a list of diagrams, which diagrammatic notations such as a rounded rectangle, certain arrow markings, we had a diamond inside it. We had a rectangle which was slanted, which we call it as a parallelogram, and so forth. With all those symbolic notations, we'll try to depict the algorithm that we have written so that it can be very easily understood by even the common person. So we have seen earlier there was one algorithm which we have written for calculation of square of a given number. Now with that algorithm, we will try to convert it into a flowchart. Remember, in the flowchart, the rounded rectangle, or in simplest terms we call it as ellipse, is used for representing the start and stop symbol. Start and stop symbol will be used will be represented using the rounded rectangle. Whereas whenever you take any input from the user or give the output to the user, you will represent it with the help of a slanted rectangle or parallelogram. Input and outputs will be represented using parallelogram. And whenever certain computations are to be done, those computations will be represented using a normal rectangle. And if any decision is to be made, those decisions will be depicted using a diamond or which we can call it as a decision notation. So, as I said, there will be a slip test which I will be keeping, and for that slip test, kept this particular points for you to be done. There will be an exam. I'll let you know when I'll keep that exam. Whenever I'm keeping, I'm going to take these two questions and give it to you. So coming further, we have seen that there is a difference between algorithm and a flowchart. Flowchart is basically a depiction, a diagrammatic notation, whereas algorithm is a sentential description about how you are going to solve a problem. Both represents how to solve the problem. Is diagrammatic, other is sentential form or so I have kept certain rules and regulations and what are differences. Please go through them. They are very simple. Now coming further, we have seen the flowchart and the algorithm. Now, when the algorithm is available, we have to put it down in terms of a language which the computer understands. That's nothing but you'll convert the plain English format into a programming language. Or in other words, you are going to write a program to solve that particular problem. So some people gets confused with the two terms, algorithm and program. Algorithm is a simple plain English description about how you are going to solve a problem. Whereas a program is going to contain a lot of rules and regulations which you have to follow, as well as you have to adopt to a particular language which is understood by the computer, and you have to write your entire strategy how you are going to solve the problem in that particular format only. But in case of algorithm, there is no certain rules and regulations. If you know English or your own language, you will just put it down step by step how to resolve the problem. But in case of program, you need to follow certain rules and regulations and certain syntaxes, grammatical ways which we will communicate with the computer. So in in short, we can say whenever we are trying to resolve a problem, in the designing phase, in the plan strategy phase, you will come across with the algorithm. When you are going to actually implement it out on a particular computer, then you have to write a program. So now the question is, how or which language does the computer understand? To know about it, we have started with very first basic language, which is C language. And with this C language, we'll proceed further and try to understand it. So if you have seen this particular topic, I have revised because some people have missed it or it was cut short due to lack of time. So I have just recapped back all those things. So I have kept this as a slip test again back for you. I'll be asking you to write down 5 differences between an algorithm and a program. So you need to be prepared for it. Now coming on for the programming languages. When we want to talk with the computer, we know that computer is just an electronic device. It's nothing but electronic. So when we are talking about electronic device, that electronic component is called as hardware. The electronic component is called as hardware. And this hardware understands only and only electrical signals. It doesn't understand anything else. If we want to talk with it, we need to speak in terms of electrical signals, which is impossible for a human being. So what researchers have done is For the electrical signals, let us say +5 and -5 volts are given for the power supply. They have taken the +5 as 1 and -5 as 0. Some of the electronic components work with +5 and -5. Some of them will work with +12 or -12. Some will work with +25 and -25. So whatever may be the electronic signal requirement, power voltage requirement of the electronic device, the depiction for on symbol is 1 and for the off symbol is 0. So in short, we will try to talk with the hardware in terms of machine language, which is ones and zeros. Now again, can a human talk in terms of ones and zeros for everything? Suppose I want to pass a message, hi, how are you? Even that hi, how are you has to be converted into ones and zeros. Can we talk? No, it's not possible. So what researchers have done is they have again worked on and made a software called as assembler, which will try to pick up commonly used words, and they have given a nickname to the ones and zeros of those commonly used sequence of ones and zeros. Let us say adding of two numbers. Always will use add x and y. Now x and y can be changed with a and b, c and d, or whatever names you want to give, but the name add will be as it is. So for add, they have a nickname ADD. This ADD is called as, or nickname is called as mnemonic. But again, there is a problem. How many mnemonics can you memorize and can you understand? And can everything be represented in terms of mnemonics? No. So in order to have a general language, in order to have a good communication, we are not able to use assembly language. We are going for a higher level language which is very compatible with human understanding. It should be very easy for a human being to speak out. That high level language has been developed by various researchers, and many have given, there are thousands of high level languages. Among them, some of the very famous languages are C, C++, Pascal, Java, C Sharp, and there are various other languages, Python, Perl, Ruby, all those are languages. But out of all of them, we are starting with C language, which becomes the fundamental language for all other languages. I hope this concept is clear why we are going. Now let me revise it back why we are going for a particular hardware. We know that computer is just an electronic device, which is nothing but hardware. Now, in order to speak with the hardware, we need to speak in terms of electronic voltages, which we cannot do. So we have represented electronic voltages in terms of ones and zeros. Okay, on with 1 and off with 0. Now, even those ones and zeros cannot be easily memorized and cannot be used by a human being. So we have come across with some commonly used sequence of ones and zeros, and we have given a nickname for them. Let us say add, subtract, multiply, move, jump, all those nicknames. Those nicknames are called as mnemonics. And the language which is built up of mnemonics is called as assembly language. Now, how many mnemonics can you memorize and can you use? There is a limitation. It's not general purpose. So we have moved further to a commonly used language which can be easily memorized and which can be easily used up. That commonly used language is nothing but high level language, which is very close to human understandable languages. Let us say English. So any programming language which contains English type of notations, English type of words is called as high level language. There are thousands of high level languages presently in the market, with all of them having their own importance. And the very fundamental language which comes as a basic background for all other languages is C language. So I've kept the same thing back over here in terms of sentential formats. Programming language defines a set of instructions that are compiled together to perform a specific task. Who is going to perform the task? CPU. Be careful. Whereas in case of algorithms, you are going to write it down because you want to understand the flow of execution. In case of programming language, that flow of execution should be understood by the CPU. So when we are talking with the CPU, when we are instructing this CPU, then we need to talk in terms of programming language. So take any programming language, it contains a unique set of keywords and syntaxes. Keywords are those words which have got their meanings already understood by the computer. So these keywords we'll use and we'll use it in a proper grammatical form. That grammatical form is nothing but syntax. Okay, so coming next, when we talk about programming languages have been classified into two categories. One is low-level language, second is high-level language. Low-level languages are assembly language and machine language because they were very difficult for a human being to use in order to communicate with the computer. These two are called as low-level languages. Whereas high-level languages are very close to human understandable languages like English language. That's why this is separate. So there are two types of languages based on how they provide the details of implementation. That's detail of implementation is called as abstraction. Based on the levels of abstraction, there are two categories. One is low level and second one is high level. So when we talk about low level comes into two categories. One is machine language, second is the assembly language. Machine language is built up of only and only zeros and ones. This can be directly understood by the computer. We cannot speak in that terminologies, ones and zeros. Take everything in ones and zeros, which is impossible for a human being, right? So this a language which is there in ones and zeros is called a binary language. Is called as binary language. So creating a programming machine language is very difficult and it is not easy. So what researchers have been done, they have picked up used words and they have defined the ones and zeros sequence for those commonly used words in a software called as assembler. So whenever we use those commonly used words, assembler will automatically substitute ones and zeros and then send it to the computer. So computer will do the work. So assembler will act like a mediator or translator between us and the computer. But again, assembly language is having its limitations. It's very limited. How many mnemonics can we create? Very limited, right? So that's why we are moving ahead for high level language. High level languages are independent of a particular type of computer. For example, if I say 1 is representing plus 5 and 0 is representing by minus 5, there may be another company which is making computer which will say, no, no, no. I will say plus for minus 5 and 0 for 5. Plus 5. Our entire program will become out of control. It will become completely upside down. Should we define another program? No, no. If we are doing, if we are using machine language, then we will be facing that trouble. But if we are using a high-level language, we need not worry about it. The internal details of the computer may be whatever the computer manufacturer wants to use. We'll use a compiler which will translate our English code into the computer required code. Okay. So that's why high-level languages are independent of a particular computer. Now, why do we call high-level language? There was one situation where I was there in a particular gathering, and we asked, like, do you call C language as a high-level language for one of the students? That student replied, because we have learned it in higher studies. After school, we have learned it. That's why it's called as high level language. Not like that. High level language is a language which is very close to human understandable languages, whereas machine level languages, assembly level languages are very close to computer understandable format. That's why assembly and machine are called as low level languages, whereas C, C++, Fortran, and so on and so forth are called as high level languages. So whenever we want to use high level language, we need to have a software which will translate whatever English code we are writing into the machine level or assembly level language, which should be understood by the computer. So that software is called as compiler. What are the advantages of high level language? It's easy to get to know. First thing, it's easy to read and write because we use commonly used English language. Will overcome all the limitations that were there in terms of low level languages and the portability issue. Portability in the sense you develop the program once and it will run on different computers. Whereas if you write the same program in machine language, that program will not work for different companies. You have to define it once again, which becomes a very difficult task. So the differences between low level language and high level language, please go through it. It's not a bigger task. Whatever we have discussed in the previous slides has been recapped back over here. So now let's try to understand this particular sequence. We were in this sequence and our class finished off. I hope it doesn't happen now. We'll finish this sequence and please do follow. This is very important question for your entire career, not just talking about your marks. For your entire career, if you are looking for computer industry, if you understand this sequence, you can understand anything. But if you don't understand this thing, you will face a lot of difficulty in understanding further flow of program executions. So first thing, we'll write a program. This program, we'll write it in English language, high level language. We'll use English like words. This program is called as source program or source code. This program is called as source code. Now, this source code at present moment we are using C language. We know that there are various high level languages, right? We are using C language. Whenever we write any C language program, we will save it with the extension of .c. Whatever file name you want to give it with the extension of .c. This high level language cannot be understood directly by the computer, right? So we need a translator in between us and the computer. So the translator is nothing but compiler. So whatever I'm going to write now here with the green ones is going to be a compiler as a whole. Okay. Compiler has various internal components. I have listed all the components line by line. Please follow it. So compiler will take the C program which we have written as a source code. And what it will do is it will try to whatever we have written here in this particular source code, we'll write certain logic which is defined by us. And while doing the work, there may be some logic which has been already written by someone else, and we want to use it. We don't want to freshly define it out. Just like, for example, to print something on the computer, I need not write every step to print back on the computer. I'm just calculating some calculation like multiplication of two numbers and I want to print it back on the monitor. To print it on the monitor, I have to define one logic. To calculate multiplication of numbers, I have to calculate another logic. So instead of someone has already written a logic for printing on the computer, I'll just reuse it out. So what compiler will do is it will pick up all those previously defined definitions which are there in preprocessor directives. It will substitute wherever we are trying to use them here in our C program, and it will try to pass that particular program to a error checker. Yes, compiler will check for is there any error, syntactical error or grammatical error, as well as it will also check for is there any uh, issues with your program which is going to make a high impact on your computer. So once this program is perfect, error free, it will be passed on to another component as a target assembly code. So what is happening, whatever C program high level language was there, it got converted into assembly level language, which is containing mnemonics. This assembly language cannot be directly understood by the computer. It needs to be translated into ones and zeros again, which is machine language. So to translate it, just like how we are having source code to assembly language, we have a translator for assembly language to machine language. The translator is called as assembler. It's called as assembler. Now this assembler will take the assembly language which has been generated by the compiler and it will
చెప్పేది కూడా ఏంటంటున్నా నిన్న మంచి క్లాస్
another component as linker.
సప్పుడు
This linker will try to take whatever has been generated by the assembler as an input. What assembler will generate is it will try to generate a system architecture dependent object code. This object code is not exactly ones and zeros. The thought was our high level language, English language, was getting converted into mnemonics assembly code. Now, assembly code was actually to be converted into ones and zeros. But what will happen is assembler will convert it into whatever system architecture is going to use. +5 for 1, -5 for 1, whatever system architecture is using. It will try to make that system architecture dependent object code. This object code is not a complete program. To make it complete, we need a component called a linker. This linker will pick up all the additional library files which are required for further making this program to be completed. So what happened? We wrote our English language program which was called as program.c. It got compiled into a target assembly code. This targeted assembly code was assembled into prg.obj. This is intermediary language format. If you open it, you cannot understand this language. It will have unreadable characters inside it. But do remember, it is not exactly ones and zeros. It is intermediary code, okay, called as object code. Now, this object code will be taken by the linker, plugged in with all of the library files which are required for making this program to be completed. Like, for example, I'm trying to print something on the monitor. I've written logic for printing on the monitor. Whether the monitor is available or not, we require, in order to speak with the monitor, certain rules and regulations to be followed. Those rules and regulations will be specified in library files. Okay. So our program, along with those rules and regulations, will be plugged in. And once they have been linked up, this linker will generate a code called as prg.exe. This code is exactly in machine language, in ones and zeros. Okay, so our prg.c got converted into prg.obj. prg.obj have been converted into prg.exe. Now, is our program ready to get executed? No. It has to be passed into a component called as loader. This loader will pick up this prg.exe, check whether your computer processor is free to execute the code or not. If the processor is free, it will be sending the code to execution. But how to check whether the processor is free or not? The checking can be done by putting the program into memory. Like, for example, whenever we want to install any software on our mobile, if there is RAM space available, then only we can install. If there is space in the in our mobile, then only we can install, right? That installation is not nothing but execution of the program actually. So loader will check is there any proper space available inside your RAM or not. If the space is not available, it will try to allocate the space and it will try to load that particular program, which program prg.exe into RAM memory space. So loader will pass that to memory component, and once inside the memory, in computer, what will be the memory? RAM memory. So once the program is inside memory, is ready to get executed by the processor. Whenever the processor is free, it will pick up the program from the memory and it will execute it. So from the memory, processor will pick up the program. Based on the program, if the program requires any input, that input will be taken from the input devices. And if the output is generated and it is to be displayed out onto a display device or to a printer, it will get printer or display device. The output will be displayed out. So I hope you have clearly followed the entire sequence of execution. I don't want to hurry up. Please go through this sequence carefully because if you don't understand this sequence, it will be very difficult for the remaining topics in this unit. So that's why I want to further revise it out once again. Let's get from the beginning. We have our source program first, which is our C language program. The C language program will be given for compiler to compile it because C language is written in English language, English-like language, which cannot be understood by the computer. But English-like language should be converted into ones and zeros, which can be understood by the computer. Now, in order to convert it, we are making use of compiler. Compiler will do, it will pick up the definitions which are needed. The short forms which we have written here in our program, its definitions, it will pick it up, combine it, try to check whether errors are coming in this particular program. If there are no errors, it will pass on that particular data as a assembly code, which is a intermediate representation of ones and zeros in mnemonic formats. And it will pass on to a component called as assembler. This assembler will take up that particular component and pass it on to a component called as a linker. Linker will take that particular object code, which is not completely a ones and zeros component, and it will try to pick up whatever further software components are required to make this program to work completely. It will pass it on to component called as loader. What it will generate, what the linker will generate, prg.exe, and it will pass it on to loader. Loader will check whether there is sufficient memory available in the RAM space or not. If the memory is available, it will pass that particular prg.exe along with the operating system files to your memory. Once the program is inside RAM memory, it can be up by the processor and the processor will take the input and generate the output. This is the simplest flow of your entire execution. So I have kept further description about each of the component here, which we will discuss tomorrow. Not in a hurry to finish it up because this is very important. Based on this only, you will have further topics to be. Okay. I hope you have understood all. If you have any doubt, you can unmute yourself and ask it. We have around maybe 3 minutes left out. You can even post it in the chat box.
నిన్న ఈవినింగ్ 10 క్లాస్ అయిందా మీకు? ఆడ 3 గంటల నుండి స్టార్ట్ అయింది కదా, మళ్ళీ ఉంటుంది.
Is there any doubts for anyone in this particular topic? Today, at least around 18 members have joined. The strength is increasing. 19. Don't worry, I'll get to at what time you are logged in and logged out. So don't think that if you are joining at the very last moment, you will get the attendance. Okay, ma. I'm further waiting for the doubts to be cleared up. If there are further doubts, you can raise it up. If you don't have any doubts, we'll close off the session. So let's close this session now. Thanks for your interest in listening.